Next question. Y of t equals cos of x of t. Y of t equals cos of x of t. Check for linearity. Check for linearity. So first write on general equation. We have a1 x1 of t plus a2 x2 of t. So according to this equation, cos of x of t, we can write on this as a1 cos x1 of t plus a2 cos x2 of t. So this is equation 1. If we apply that to a system, this a1 x1 of t plus a2 x2 of t. So the whole is acting as the input, that is cos of a1 x1 of t plus a2 x2 of t. So once we compare the equation 1 and 2, both are not equal. So the given system is non-linear. So the given system is non-linear. And cos of x of t indicates it depends on the present value. So satisfies the second property. The given system is a causal system. Conclude the second statement. And the system depends only on the present value, so it is not having any memory. It's a causal system and memoryless. and then check for time invariance. So across input side, it is cos of x of t minus t naught. That is for input side. Across output side, wherever we have a t, replace t by t minus t naught. So that is cos of x of t minus t naught once again. So equation 1 is equal to 2, the time invariance. The system is time invariant. The given system is non-linear, it's a causal system and memoryless, and it satisfies the time invariance property, and always it's a stable condition. What is the next question? Y of t equals x power t by 2. Y of t equals x power t by 2. So check for linearity. the general equation is a1 x1 of t plus a2 x2 of t. So this can be written as a1 x1 power t by 2 plus a2 x2 power t by 2. Call it as equation 1. And normally, if you are going to apply the whole thing into the system, a1 t of x1 of t plus a2 t of x2 of t. So once you apply x1 of t to the system, it gives the output as x1 power t by 2. Once you apply the input x2 to the system, which gives the output as x2 power t by 2. So equation 1 is equal to 2. So it's a linear system. So x power t by 2, it depends on the present value. So it's a causal and memoryless, and check for time invariance. Respect to time invariance, so normally we are shifting the thing by t naught, so that is across input side. Label it as equation 1. But for output side, that is for y of t minus t naught. That means wherever we have a t, replace by t minus t naught. So that x power t minus t naught by 2. This is equal to x power t by 2 minus t naught by 2. So 1 is not equal to 2. It's a time variant property. It satisfies time variant. It's not a time invariant because 1 is not equal to 2.
Excuse me, sir.
ಹೇಳಪ್ಪ.
ಸರ್ ಇದು ಸಿಸ್ಟಮ್ಮು ಅದು ಪ್ರೆಸೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ, ಫ್ಯೂಚರ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ಹೆಂಗ್ ಕಂಡುಹಿಡಿಯೋದು?
So x of t concludes origin. X of t concludes origin. X of t plus 2 concludes, it's a future value. X of t minus 2 concludes past value. So here we have a x power t by 2. So it is not x power t plus 2 by 2 or t minus 2 by 2. So this depends only on the present value of the input. That's why we conclude that as the system depends only on the present value. So it is a causal system. If it is t plus 2 or t plus something or t minus something, then we conclude this as future and this one as past.
Okay, sir.
Got it?
Yes, sir.
Yeah. Ready the next question. Y of t equals y of n equals 2 into x of n into u of n. Two into x of n into u of n. So wherever we have a x of n, so write down there as a1 x1 of n plus a2 x2 of n. So 2 into x of n into u of n. So wherever we have a x of n, so just write down that as a1 x1 of n plus a2 x2 of n. And then retain the remaining same as it is. Afterward, this one can be written as 2a1 x1 of n into u of n plus 2a2 x2 of n into u of n. Therefore, it has equation 1. But normally, we can able to write down as weighted sum a1 t of x1 of n plus a2 t of x2 of n. So once we apply x1 of n to the system, so it gives the output as 2x of n into u of n, a1 into 2x1 of n into u of n plus a2 into 2x2 of n into u of n. So equation 1 is not 1 is equal to 2. So the given system is linear. And x of n concludes the present value, so it's a causal, and it is not having any memory because of present value. And then check for time invariance. So the time invariance across input side, so x of n minus n naught, so 2x of n minus n naught into u of n. But for across output side, replace the whole thing n by n minus n naught, so that 2x of n minus n naught into u of n minus n naught. 1 is not equal to 2. It's a time variant property. That is the next one. Y of n is equal to n into x of n. N into x of n. Solve. to check for linearity. Is it linear or non-linear?
Linear.
Linear.
Yeah, the given system is a linear system. And is it a causal or non-causal?
Causal.
Causal.
So it's a causal and memoryless. Is it satisfies the time invariance property? Is it time invariance or time variant?
ಸರ್ ಟೈಮ್ ವೇರಿಯಂಟ್ ಪ್ರಾಪರ್ಟಿ ಒಂದು ಮಾಡಿ ತೋರಿಸಿ ಸರ್ ಈ ಪ್ರಾಬ್ಲಮ್ಗೆ.
So just look at here, all of you. So first we need to check for input. So input concludes. So just for x of n, we need to write on that as x of n minus n naught for a discrete. For a continuous, if we have x of t, we have to make it as x of t minus t naught. So in this problem, we have a n into x of n. So just we are going to write down only for a input side. We are going to perform the shifting operation only for a input side. Here the input is x of n. It is not n. N is just a constant term here. So x of n is acting as a input. We need to perform the shifting operation only for a input side. So input side is x of n minus n naught. So this is the first step. So that is we need to write down only for input side. N into x of n is there. 2 into x of n into u of n irli. 2 into x of n into delta of n other irli. ಏನಾದ್ರು ಇರಲಿ, but wherever we have input controls always the variable x. So x term ಮಾತ್ರ ನಾವು we need to write down the shifting operation as x of n minus n naught. So label it as equation 1. Across output side means y of n minus n naught we conclude as an output side. Here wherever we have a so look at the output equation is y of n is equal to n into x of n. So y of n ಇದೆ n into x of n ಇದೆ. y of n minus n naught ಅಂದ್ರೆ ಅರ್ಥ ಏನು? So y of n is equal to n into x of n. Y of n minus n naught is equal to wherever we have a variable as n in this particular equation. ಈ equation ಗೆ ನಾವು ಎಲ್ಲಿ ನಮಗೆ n ಟರ್ಮ್ ಇದೆಯೋ ಆ ಓಲ್ಡ್ n ಟರ್ಮ್ ನ ನಾವು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತೇವೆ n by n minus n naught ಅಂತ. So here we have a variable as n, so that we need to replace by n minus n naught. And then here also we have a variable as n, that is x of n. So there also we need to write down that as x of n minus n naught. So now compare the equation 1 and 2. If it is equal, it is a time invariance property. If it is not equal, then we conclude that as a time variant property. ಅರ್ಥ ಆಯ್ತಾ?
ಎಸ್ ಸರ್.
ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ. ಸೊ ಇನ್ಪುಟ್ ಅಲ್ಲಿ ಬರೀ ಇನ್ಪುಟ್ ಸೈಡ್ ನ ಮಾತ್ರ ಶಿಫ್ಟ್ ಮಾಡ್ತೀವಿ, ಬಟ್ ಅಕ್ರಾಸ್ ಔಟ್ಪುಟ್ ಸೈಡ್ ನಮಗೆ ಎಲ್ಲೆಲ್ಲಿ ವೇರಿಯಬಲ್ ಇದೆ ಅಷ್ಟನ್ನು ಕೂಡ ಶಿಫ್ಟ್ ಮಾಡ್ತೀವಿ. So 1 is not equal to 2 here, so that is time variant property. In the same way, in the next problem. So it is guarantee one question ಬಂದೇ 6 to 8 marks. ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ, ಕಂಪಲ್ಸರಿ ಕ್ವಶನ್ ಇದು. ಸುಮ್ಮನೆ ಕೂತ್ಕೊಂಡ್ರೆ 10 ಮಾರ್ಕ್ಸ್ ಕಳ್ಕೊಂತೀರಾ, 8 ಮಾರ್ಕ್ಸ್ ಕಳ್ಕೊಂತೀರಾ. y of n is equal to log of x of n. So what is the first step here? Wherever we have a x of n, we need to write down that whole term as a1 x1 of n plus a2 x2 of n. So this is the first equation. But normally we have a general equation as a1 applying to the system, that is x1 of n plus a2 applied to the system x2 of n. So once we apply x1 of n to the system, what's the output here? So t of x1 of n again ಬರುತ್ತೆ.
x1
So t of x1 of n is equal to
Log of x1 of n.
Yeah, log of x1 of n. T of x2 of n is equal to log of
Log of
x2 of
x2.
n. So compare the equation 1 and 2. It is not equal. So it's a non-linear. Is it a causal or non-causal?
Causal.
Causal. And it is not having any memory because of present value. So always you should conclude the statement before concluding the causality. So the given system depends only on the present value of the input, so it satisfies the causality. Like that you need to write on the statement. In the same way, the given system depends only on the present value, so it is not having any memory or memory less. Write on the statements. What about time invariance property?
Time invariance.
It's a time invariance. So input is equal to output, so time invariance. Right on the next problem. Y of n is equal to x of n into summation k from minus into plus infinity delta of n minus 2k. Is it a linear or non-linear? Is it linear or non-linear?
Non-linear.
Check properly. So first, wherever we have an input term, write down that as a1 x1 of n plus a2 x2 of n. Just look at the previous problem here. We have a log of x of n. So wherever we have a x of n, write down that as a1 x1 of n plus a2 x2 of n. In the same way here we have x of n. So write down that as a1 x1 of n plus a2 x2 of n whole multiply with summation delta of n minus 2k. So if you are going to multiply that, so a1 x1 of n summation delta of n minus 2k plus a2x2 of n summation delta of n minus 2k. So this is the first equation. So write on the next one. Look at here. Look at the previous problem. So this one is the next one. The next step is a1 t of x1 of n plus a2 t of x2 of n. So t of x1 of n is equal to t of x1 of n ಏನು ಬರಿಬಹುದು?
x1 of n summation n minus 2k.
So x1 of n summation delta of n minus 2k plus a2 into x2 of n summation of delta of n minus 2k. So compare the equation 1 and 2. Is it equal? 1 and 2, is it equal?
Yes, sir.
So 1 is equal to 2, so it's a linear system. ನೀಟಾಗಿ ಎರಡು ಸ್ಟೆಪ್ ಫಾಲೋ ಮಾಡಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಎಲ್ಲ ಹೋಗುತ್ತೆ. And this is a causal and memoryless, and it is a time invariance or variant.
Time variant.
ಏನಾಗುತ್ತೆ? Time
Variant.
So time variant. So equation ನೋಡಿ ತಕ್ಷಣ ಹೇಳ್ಬೋದು ಟೈಮ್ ವೇರಿಯಂಟ್ ಇನ್ವೇರಿಯಂಟ್ ಅಂತ. ಜಸ್ಟ್ ಇನ್ಪುಟ್ ಇತ್ತು ಬಂದ್ರೆ ಬರೀ ಎಕ್ಸ್ ಆಫ್ ಏನಾದ್ರು ಎಕ್ಸ್ ಆಫ್ ಟಿ ಅಷ್ಟಿತ್ತು ಅಂದ್ರೆ ಮಾತ್ರ ನಮಗೆ ಇನ್ವೇರಿಯನ್ಸ್ ಆಗುತ್ತೆ. ಯಾವ ನಮಗೆ ಅಡಿಷನಲ್ ಥಿಂಗ್ಸ್ ಬರುತ್ತೋ ಡೆಲ್ಟಾ ಆಫ್ ಎನ್ ಮೈನಸ್ 2k ಯು ಆಫ್ ಎನ್ ಎಕ್ಸ್ ಆಫ್ ಎನ್ ಪ್ಲಸ್ 2 ಯಾವ್ದಾದ್ರು ಅಡಿಷನಲ್ ಥಿಂಗ್ಸ್ ಬಂದ ತಕ್ಷಣ ಟೈಮ್ ವೇರಿಯಂಟ್ ಆಗುತ್ತೆ. So anybody is having doubt, you can clarify. So with this, I'm going to end the class today. So you can enter your attendance and then you can leave the meeting.